Yes, good morning, grade 10s. My name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences, grades 10 to 12. Now, this morning I want to take you through waves, sound and light to prepare you for the test tomorrow, because I know some of you are scared, some of you are not ready. Now, those learners who attend with us at Smart Math extra classes at Rostec College, also you take this opportunity to watch this video. I believe it will do great wonders in your life. Yes, let us proceed. Now we're looking at the waves, sound and light. Now for the sake of our test tomorrow, we're looking at only transverse waves and transverse pulses. Okay, so I'm starting with the important terms and definitions. Number one is the medium. A medium is the material through which a pulse or wave travels or is propagated. For example, sling a spring, water or air. Okay, let us proceed here. Then what is a pulse? A pulse is a single disturbance that is propagated through a medium. A pulse is a single disturbance that is propagated through a medium. So our pulse looks like this one here. Let's get one here. Let us get one. This is how the pulse looks like. Let me use yes, I think yeah, red is fine. Now this is how the pulse looks like. It can be like this. Now this is my pulse here. Okay. Next is the amplitude. Now the amplitude of a pulse is the maximum displacement of a particle of a medium from its rest position. Let us find it out here. Now what is amplitude is what we mean here. Now amplitude, I mean the distance from here up to here. So if I may draw the amplitude for this one here, it's going to be from this point. Let me use now a yellow color. Hopefully bring it up properly. Now this is my amplitude. This is my amplitude. That is from the top to the rest position here. Okay. Then next we have what we call as the pulse. The pulse length is the distance between the two ends of the pulse. So if we check our pulse again, now this is our pulse length here. If I may use blue now, it's gonna be from here. Yeah, it's our pulse length in blue. Because from this point up to this point here. So this is the pulse length. This is amplitude. Okay. Now the pulse length is seen along the line which is called the rest position. So this is the rest position, or you can call it equilibrium position. Okay, let us proceed. Okay, so that is the position at which the medium is at rest. That is the position at rest. Let us proceed here. Now, another term here is called transverse pulse. Is a pulse in which the particles of the medium move at right angles to the direction of propagation of the wave. Let me explain what I mean here. Now look at these two lines here. Let me use the red one. I think it's gonna bring it out properly. Okay. Now look at this line here. if our pulse is moving this direction, okay, this direction here, okay, and then we have our pulse like this one here. If this is the pulse here, if this is the pulse, as you can see, this is its direction, okay, going to the right. And then now, as you can see, our pulse, it has been displaced upwards. By the way, some pulses can be displaced upwards, others can be displaced downwards. Okay, downwards I mean like this. Check this out, like this one here. Now this one is displaced downwards, this one is displaced upwards. Now if you check properly with my pulse, you can see that this one has been displaced upwards like this. Has been displaced what? Upwards like this. So because this pulse has been displaced upwards, you can see that the angle between direction of motion and displacement of the pulse is what? It is 90 degrees, or it is perpendicular. So a pulse whereby the displacement is perpendicular to the direction of motion is called a transverse pulse. So this one here is called a transverse pulse. Hope we are together. Now these pulses can interfere. They can interfere like this one here. Now that one brings us to interference. So interference is the phenomenon that occurs when two pulses meet at this as they move through the same medium. So when two pulses meet as they move through the same medium, they interfere. In other words, they're going to give us a resultant amplitude which can be either higher or lower than any of the interfering pulses. Okay. Now we have got types of interferences, what we call as constructive interference and then destructive interference. Now constructive interference occurs when the pulses overlap and the resultant displacement of the medium increases at the point of overlap. And then destructive interference, it occurs when pulses with displacements in opposite directions overlap and the resultant displacement of the pulse of the medium decreases at the point of overlap. Let me explain this, but before that, now these pulses, when they interfere, we use the principle of superposition to get the resulting amplitude. So this is how it states that the addition of the displacement of two pulses that occupy the same space at the same time, the resultant displacement of the medium is the algebraic sum of the displacement of the individual pulses. Maybe you can see what am I talking about here. Let me show you this properly. Let me show you this one here. Now note here, I have got these two pulses here. Either is this the line? Let me say if this is my equilibrium line here. Okay, this is my rest position, and I have this pulse, and I have this pulse, which moves like, which faces this, which looks like this. So if this is my pulse here, okay, and as you let me say this pulse is moving to the right, okay, moving to the what? To the right. As in this its direction is moving to the right. Okay. If I have another pulse from this other side, that is from the right going to the left, for example here. Okay. Now this one is moving to the left. Okay. the left. Now these two pulses, if this one has got amplitudes of, let me say, 3 meters, that means from here to here, okay, and then this one has got amplitude of 1 meter, okay. Now when these two pulses meet at this point here, let me say if this is point X, okay, now the resulting amplitude is given by the principle of superposition, whereby we simply add this 1 plus the 3. So what is 1 plus 3? It gives us what? It gives us 4. So now our resulting amplitude at point X is going to be like this one here. It's going to be like this one here. Now because we said 1 plus 3 gives us 4, now this is going to be the resultant one here. It's going to be giving us the 4, which is now our resultant amplitude. Now as you can see, this pulse and this pulse, they've got lower amplitudes than the resultant pulse. So because we have constructed a resultant pulse with a higher amplitude, it means this type of interference is called constructive interference. However, if I had something like this now, watch this, like this now, and I have my position of rest like this one here. Now this is my equilibrium position, or you can call it position of rest. And now this time I have my two pulses again, like this. Now if this one here is also, let me say, 3 meters, okay, let's move into the right, okay, to the right, and then another pulse which is now facing downwards. Let me say again, if this is 1 meter amplitude, okay, also moving to the what? Moving to the left. So after a certain time, these pulses are going to meet here at point X again. This is my point X where the pulses are going to meet. Now note something, that this first pulse is moving to the right. What about here? Moving to the left. Now when the two pulses meet here, guess what? They're going to have an amplitude using the principle of superposition which is lower than this one here. Actually, because this one is facing up, it's going to be like this. It's going to be like this one here. Now this time it's like I'm going to that positive 3 plus negative 1. It gives me positive 2. So as you can see, this is my resultant pulse with amplitude of 2. Now this 2, because it's the resultant and I was having 3, as you can see, I have destroyed one of the amplitudes of the pulses before, that is from 3 to 2. So because I am destroying the amplitude, like I'm decreasing the amplitude, this one is called destructive interference. It's called what? Destructive interference. Not something that if this was positive 3 and this was negative 3 down here, now my amplitude would be 0, and that is called total destruction. I hope guys we are together. Let us proceed, because I want to do for you an example. Okay, so that was about what interference is. Now note something, that if I have those transverse pulses in succession, then I form a transverse wave. So a transverse wave is a succession of transverse pulses, or you can say it is a wave in which the movement of the particles of the medium is perpendicular to the direction in which the wave moves. Let me say it again. If we say define a transverse wave, you can say that it is a succession of transverse pulses, okay? Or you can say that a transverse wave is defined as a wave in which the movement of the particles of the medium is perpendicular to the direction in which the wave moves. The wave moves. So these are two definitions of the same term, but they all mean the same. They all mean transverse wave. I said it is a succession of transverse pulses, or simply it is a wave in which the movement of the particles of the medium is perpendicular to the direction in which the wave moves. Okay, let us proceed with other terms. Now, on a transverse wave, we have what we call as a crest and a trough. A crest and a what? And a trough. Okay. Now you can say what is a crest, what is a trough. This is how they look like. Now, if this is my transverse wave, okay. Now this is my first pulse, which is transverse. So if I add another transverse pulse in succession, like this one here, okay, and then I have this one as my rest position, this one here. If this is my rest position here, that is from this point here up here. If this is the rest position here, now our maximum displacement, which is positive, or you can say which is upwards, that is from here to here. Okay. Okay, our point. Okay, the crest of a wave is the point on the wave that represents the maximum positive or upward displacement of the medium from the rest position. As you can see, now this wave, its crest is this point here. So this is the crest here. This is the crest here, and then this one is called the trough. It's called what? The trough. Okay. Hope we are together. Let us proceed. So a trough of a wave is a point on the wave that represents the maximum negative or downward displacement of the medium from the rest position. Okay, now we have what we call as wavelength of the transverse wave. Now wavelength is the distance between successive crests or successive troughs, or you can say the distance that a wave moves during the generation of a complete wave. We're going to see that. I'm going to explain that more. Then period T of a wave is the time taken for the source of the wave to complete one oscillation or vibration of the medium. Or you can say that the time taken for a single complete wavelength to pass a fixed point. I prefer this definition here for period. I said it is what? You can say that the time taken for a single complete wavelength to pass a fixed point, and this period time is measured in seconds. Okay, let us proceed. Now frequency of a wave is the number of complete waveforms, or you can call them vibrations or oscillations, that pass a fixed point each second. Frequency equals to 1 over t. T is the periodic time, and the frequency is measured in hertz, Hz. Okay. Then we have what we call as points in phase. Those are points that are one wavelength apart. let me say it again. The points in phase, they are points that are one wavelength apart. I'm going to explain this in more detail as we proceed. Then points out of phase, the points that are more or less than one wavelength apart. And then speed of the wave, V. The speed is the product of the frequency f and the wavelength of a wave. We measure the speed in meters per second. Okay, so that is to do with the transverse wave, and that's where our text ends. But the other terms said it to do with longitudinal waves. Now, what's a longitudinal wave? It is a wave in which the movement of the particles of the medium is parallel, that is, forwards and backwards, to the direction in which the wave travels. Okay, and then a compression is a region in a medium through which a longitudinal wave travels, where the particles, let me zoom it here to make it more visible. Okay, I'm saying that about longitudinal wave, about longitudinal wave. Now the term is called a compression. A compression is a region in a medium through which a longitudinal wave travels, where the particles of the medium are compressed or pushed together. Then another term is called rarefaction. A rarefaction, it is a region in a medium through which a longitudinal wave travels, where the particles of the medium are pulled apart. And then wavelength of a longitudinal wave is the distance between the center of successive rarefaction or successive compressions. Okay, and then amplitude of the longitudinal wave is the maximum displacement of a particle of the medium from the rest or equilibrium position. Let us proceed. Then frequency of longitudinal wave is the number of compressions or rarefactions that pass a fixed point each second. And then the period of the longitudinal wave is the time taken for two successive compressions, or you can call them rarefactions, to pass a fixed point. And then pitch is how high or how low a sound is. The pitch depends on the frequency of the sound. In other words, the higher the pitch, the higher the frequency. And then loudness of a sound is the ear's perception of the intensity of the sound. The loudness depends on amplitude of sound and the frequency. Okay, now these are the formulae which we're going to need in our calculations. The first one says period t equals to 1 over frequency, and the frequency equals 1 over periodic time, and the speed of the wave v equals to frequency times what? Wavelength. Okay, now more about the terms one more time. Now this is my transverse pulse. Okay, now it has been displaced downwards. As you can see, it's moving to the right. Now this distance from here up to here is what we call as what? We call it the amplitude. So this is my amplitude A. As you can see, it is the maximum distance from the rest position, okay, to the crest, to the trough. And then this distance from here up to here is what I call as the pulse length. This is my pulse what? My pulse length. And then, yeah, this direction of motion, as you can see, these two are perpendicular again. So this is the transverse what? Transverse pulse. And then if I check this again, now these transverse pulses, when combined in succession, they form a transverse wave. So there's a transverse wave here. Now this point here, this point here, okay, and this one, they form one complete wavelength. So this is one wavelength, also this point from this crest to this crest also form another wavelength. Okay, so if I may draw that, I can like this. I'm going to have it from here up to here. That's my one wavelength. All from this point up to here, it's another one wavelength. All it can be from this point up to here, it's also another one wavelength. All can be from here up to here, it's also another one wavelength. So now the points which form one wavelength, we say they're in phase. They're in what? In phase. And then if they are more or less, we say they're out of phase. So this point, if this is point, let me say, if this is point O and this is point D, now the distance or the points O and D, they are out of phase because they form more than one wavelength. They form more than what? One wavelength. More than one wavelength. Now this is one wavelength here. So the points formed by these three lines, each 2 points, each line here, like this one here and this one here, they're in phase because they form what? They form one complete wavelength. Yeah. Thank you so much for watching. Let us try out some examples here. Let's see what we can do here. Now these questions, they are on the group chat. You can, this one is November 2019. The question says here that the diagram below represents the transverse wave produced by source A. Okay, and then they said that so as you can see, this is from 0 to this 16 and then more. This one is our distance from here up to here. I don't know if it's that distance D. What does the question say? Now on the y-axis I've got amplitude in centimeters. Now our amplitude must be measured in meters. So if you ask in centimeters, please don't forget to convert your answers to what? To meters. Okay. Okay, the question says define the term amplitude of the wave. So what is amplitude? Now amplitude is the maximum displacement from the resting position to the crest, or from resting position to the trough. Okay. Next question. They said that write down the amplitude in meters of this wave. So this wave here, what is its amplitude? As you can see that from 0 up to here, it is 50. So this is 50 centimeters. Now I must convert from centimeters to what? To meters. So how do I do that? You know that you convert from centimeters to meters divided by what? Divided by 100. So in this particular case, it means that I'm going to have my answer as what? As 0.5. So when you get my amplitude is what? It's gonna be 0.5. 0.5. So the amplitude for this wave is what? Is 0.5 meters, because it must be in what? It must be in meters. 0.5 meters. Hope we are together. Okay, next question says that okay, what does it say now? Next question says something else. Let me just get a new page here so you can do calculations. Okay, now back to desktop. Now after that, what do they say? Now that's our amplitude there. Now they say determine the period of this wave. Determine what? Period of this wave here. Now the period is the time taken by one complete wavelength to pass a fixed point. Let's check it again here. Let's check it here again. I don't know if it's now if you check here again, now my complete wavelength can get from this point here to this point here. So here my answer is 8 seconds. for the period of this wave here is 8 what? 8 seconds. Or you can get it from this point here to this point here. Now this point here is 2. This is 2 here, goes the middle for 4 and 0. This one is 10, the middle of 12 and 8. So I can still say that it's going to be 10 minus 2, which is also giving me 8. So my period here is what? Is 8. It is 8 what? Seconds. Okay, now they say that calculate the speed of the wave if the wavelength is 0.8. Okay, now if you remember our formula, let's say wavelength is 0.8. Now because I have my period as 8, I can find my frequency, because the formula says that frequency equals to what? 1 over t. Let us find out now. Okay, so we have that they want the speed of the wave. Now the formula says that v equals to f times what? Times lambda. That is our formula. Now to get our speed v, I'm going to get my frequency f multiplied by the wavelength, which is what? Which is lambda. Okay, but for me to get my wavelength, I have to check it out. What is our wavelength? But then we have our they gave the 0.8 here, right? What about my frequency? Now again, the frequency f is the same as 1 divided by what? 1 divided by the periodic time. Anybody who remembers what was our periodic time? Now the periodic time, it is, we said it was 8, so I'm gonna have it as 1 divided by 8. 1 divided by what? By 8. What is my answer? 1 divided by 8. Let us check it out here on our calculator. 1 divided by 8 is going to be what? So 1 divided by 8 is going to be, if I come back here, now this is my calculator here. So what is 1 divided by 8? 1 divided by 8. What do we get? We get 1 over 8. If I press my SD, it's going to be 0, what? Let's check it properly. You see, it's going to be 0.125. So that is my what? That's my answer. That's my answer. So yeah, I have 0.18, rather 0.125 as my frequency. Let me proceed with my calculation. So we said we got what here? We got 0.125. 0.125. Now this is my frequency, but the question wanted to get the speed of the wave. So I'm gonna say that my v equals to f, which is 0.125, 0.125, multiplied by what? Multiplied by the wavelength, which is what? 0.8. That's 0.8. So 0.8 multiplied by 0.125. Which answer do we get? Which answer do we get here? Which answer do we get? 0.8 multiplied by what? By 0.15 to check it out. So this answer which we have now, the 0.125 rather, multiplied by 0.8. 0.8. So what do we get? You see, we get answer as 1 over 10. If I press my SD, it's going to be 0.1. So my speed is 0.1 meters per second. It is what? It is 0.1 meters per second. So this is my speed here, which is 0.1 meters per second. So This is the speed of my wave, which is 0.1 meters per second. I hope we are together, guys. Hope we are together. Let us proceed. Let us proceed. Okay, now the question continues. Let's go to the next page and we see what happens. Next page. Next page here. Okay, now next page I have, let's say first let's this one here. Okay, now here the question continues to say that calculate the distance d on the diagram. Calculate what? The distance d on the diagram. Now our distance d, I don't know if you remember, but let us find out the distance d. We have got this worksheet on your group chat. You can open this same question, that is 2019, which is paper 1 by Department of Education, and then you can play out this number before you do your test, because it might appear, like I told that many educators, including me, we want questions which are from the years which are very current, like 2019, 2018, 2020. Yes, so let's check it out now. Okay, now the question says calculate what? Distance d on the diagram. Okay, so if I'm going to check my distance d, what is it going to be? Now my distance d, if I take you a little bit back, if I take you back to my distance d, okay, let's check it again. This is our distance d here. Now distance d gets from here up to here. Let us find out in terms of the waves. So from here up to here, that's one wavelength. From here up to here is another wavelength. So it's now half of the wave, and so it's going to be 2,5 wavelength. 2,5 wavelength. And if I'm going to compute my distance d, I'm going to multiply wavelength by 2,5. So let us proceed by 2,5. I hope we are together. Now what was our wavelength? It was 0,8. So I'm going to say 0,8 times 2,5 to get my answer. I'm going to say what? 0,8 times 2,5. So this answer here, it's going to be like this one here. It's going to be 0,8 times 2,5. So if I may show this here, if I may show what I'm doing here, what I'm computing here, it's going to be 0,8 multiplied by 2,5. 2,5. What's my answer? It is 2. Actually, our distance d is 2 meters. I hope we are together. So that is 2 meters which I have here, and then yeah, that's the question end there. Let's check it out. Let's check it out. Another question says the diagram below represents the transverse wave produced by source B. Now the other one was source A, so this is now source B here. The question says that how does each of the following properties of the wave produced by section by source B compare to that of wave produced by source A? Choose from greater than, smaller than, or equals to. Now they want amplitude. So what's my amplitude for this wave now? I can see it from 0 to more than 50. The other one was 50, right? So it's going to be greater than. It's going to be what? Greater than. What about my frequency? Now frequency is the same as 1 over periodic time. What was our period there? It was 8 seconds. What about here? Here it is 4. It is 4 seconds. So 1 divided by 4 is greater than 1 divided by 8. Let me say it again. 1 divided by 4 is greater than 1 divided by 8. So the answer here is also what? Greater than. It is also greater than. Okay, now let's calculate the frequency of the wave produced by source B. I want frequency here, but frequency is the same as 1 over periodic time. So if I may complete this again, what's my periodic time here? It is 4 seconds. So it's going to be my frequency. It's going to be 1 divided by 4, which is of course 0.25. 0.25, that's my answer there. Okay, now another question here would be this one here, but I think we can stop here. Thank you so much for watching. I hope this video was of great value for your test tomorrow. Please practice and please share our video. If you're on YouTube, you can like the video and send us comments, and we're gonna reply them. Please share the video with your friends to make them ready for their test or their final examination. Now, those learners from Capricorn, I hope you understand this video as well, because your teacher likes setting questions which are very recent. So don't be surprised when she is asking these questions like this one exactly. Yeah, thank you so much for watching. Catch you again next time. My name is Patrick Kamala. I'm a tutor and educator for physics and mathematics, grades 10 to 12. If you want our extra classes, we are located at the Rosteke College in town, that's 92 Skuman. You can visit us or you can inbox me on 0785 222 041. Bye bye. See you tomorrow in the test.